This one, because we're like, it's something or less, it's adding up lots of probability. So we could do, for the first one, the probability of 7 plus the probability 6 plus the probability of 5, 4, 3, 2, 1, and 0, all out of 20. And that would be like very long, like 20, choose 7, all of that. Instead, we can just binomial cumulative. Calculator does it for us.
Okay.
So that is stats 2. Distribution F5, binomial F5, and then F2 for binomial cumulative distribution. And so what do you think we're putting in for this?
Okay. So between the data, it'd be variable or list?
Variable, always variable.
Okay. Okay.
So let's see. Any idea about lower and upper number of trials probability?
Would lower be 7?
Upper would be 7. Because we want 7 or less.
And lower would be 0?
And lower would be 0, yep.
Okay. And then when it says numeral, does that mean 20?
Yep, number of trials, 20 trials.
And then P is 0.4.
Yeah.
And then what do we hit after that?
Equals.
I got 0.16.
I got 0.4 something.
Oh yeah, 0.416. Yeah, sorry.
Okay. Let me just take a lookie. 0.416. Yep. So what do you think about B?
Okay. So the lower will still be 0. The upper would be 5.
Yep.
And then everything else stays the same.
Yep.
And you get 0.126.
Okay, a third one.
Third one, the is it anything above 15? So lower would be 15.
Correct.
Okay. Then what would upper be?
What's the highest value you can take?
100.
How many trials?
Oh, there's 20 trials, so 20.
Yeah.
So upper's 20, and then numeric trials 20, and then everything's the same.
Yeah.
You get 1.6115 times 10 to the power of minus 0.03.
So
that's 3.
Yeah, so that's like 3 zeros, and then let's say to 3 sig fig.
So it'd be 1.61. Oh, 161.
Okay.
Yeah.
And because later on you'll see, like, if you times it by 100, it'll be that percent.
Yeah.
There we go. 3 zeros, and then that 1.61. Hang on. Put that one there for that, and that one there for the middle. Grand. Got most of it.
Yep.
Okay. So let's see. All right. Exam question. How do we do this?
Okay. So when X is just 7, does that mean the upper and lower are both 7?
Yeah. So that's like but you could use binomial probability distribution, like X is 7, but yeah, just 7 and 7.
Yeah. And then the numeric trial is 15 and the P is 0.32.
Yeah.
And that gives you 0.101.
Great. B.
Okay. So for B, the lower is 0 and the upper is 4.
Yep.
That gives you 0.448.
How about, what's different about C?
C, it would be, the lower would be 0, but the upper would be 7.
That's it. And then how about D?
D, the lower would be 6 and the upper would be 15.
Yeah, that's fine. I think you know what you're doing. Let's see. So this one is just greater than 5, doesn't include 5. No more than 3 means 3 or less. At least 7 means 7 or more. Okay. Fewer than 10, so it can't be 10. And at most 8, so 8 or less.
Yep.
Alright, let's try this one.
Okay. So for the lower it would be 0, the upper would be 2. The numeral would be 12 and the P would be 0.3.
Yep.
Which gives you 0.253.
And how about B?
Okay. So when it says at least 5 reds, that could be 5 as well.
Yeah.
So the lower would be 5 and the upper would be 12.
Well done.
Which gives you 0.276.
0.276. And yeah, so the first one, it's the probability that x is less than or equal to 2. This one, probability x is greater than or equal to 5. 276 and then 253. Great. Why do I have a part C? I cut it out. Alright, how about this? Spun 30 times. Find the probability of it landing on red. Fewer than 10.
Okay. So for this, the lower would be 0
Mm-hmm.
and the upper would be 9.
Well done.
Numeral would be 30 and the P is 0.25, which gives you 0.803.
Say it again.
0.803.
803. Let's see. What would be question C?
Okay. So would the lower be 11?
Inclusive.
So 10.
Yeah. And upper.
And the higher would be 14.
Yeah, that's fine. The other way would be exclusive.
Yeah.
And
So it's exclusive, just 11 and 13 then.
Correct. Yeah. Okay. Let me see this. I'm gonna leave that one out. Let's see this. Frankie's playing a computer game. Frankie says the probability she collects at least 8 boxes is the... No, silly. Let's see this one. Jane decides he has a spinner. Yeah, let's try this one.
Okay.
I need to fix this. We need that.
So should I do question C?
Yeah.
Okay.
We already did A and B.
Okay. So for this, what you need to do... Okay. So the numerator will stay as 12. The probability is 0.3 still.
Mm-hmm.
And the lower is 0.
Yep.
And the upper is 0.04.
The upper is you have to guess until you get an answer that is less than 0.05. So I might say like 10 to the minus 3 or something.
So what do I put in for the upper then?
Like you have to keep checking.
So do I try 0.04, then 0.03, then 0.02?
No. You'll have to try like 1, 2, 3, 4. So it's 12 spins. So a spinner is on, so the probability lands on red is 0.3. She wants the probability of winning a prize to be that. So, and the number of reds will be recorded. Find how many reds are needed to win a prize. They actually didn't describe this very well. They don't say how you win. Yeah, you win if it lands on red.
Okay.
And so that's actually it's a shame. So the upper is 12, and you have to find out what is the lower to get a probability.
Oh, you guess the numbers between 12 and 0.
Yeah, but you keep 12 as the upper and try different lowers.
Okay. So we'll try 0 and 12 then first.
Well, that's 100%. They're definitely going to get between 0 and 12 reds.
Okay.
Put it in if you want. You should get 1.
Yeah, I got 1.
Okay.
And then you can try 1.
Well, half it. So try 6. Try the halfway, and that'll make it a bit quicker.
I tried 8, and it's 9.4.
Times 10 to the minus 3.
Yeah.
That was 8, was it?
Yeah, 9.48, sorry.
Like what was the lower for that one?
The lower, it was 8.
So put in 7. What does it say?
0.03.
0.03. Does that work?
0.04 to 2 decimal places.
Okay, that's less than 0.05, isn't it?
Yeah.
So I think that one's all right.
Okay.
So try 6.
Okay. 0.118.
Yeah, so that's bigger than 0.05, and so basically they win a prize if they get 7 or more reds.
Okay.
So that's how this works.
Okay.
So the probability it lands on red is 0.3. So this game a second ago was like the probability it lands on red is 0.25. This one, the probability it lands on red is 0.3.
Yep.
She wants, so there's only a 5% chance or less than 5% chance of winning, and so she says you get 12 spins. If it lands on red 7 or more times, you're the winner. You win a prize. Yep. So there you go. So 7 or more reds will win a prize. Yep. Let's see. Okay, how about these?
Okay. So we want a number that's less than 0.05 again.
Yeah.
Okay. I think 27 for A.
So K is 27.
Yeah.
And try B.
Okay.
So for that one, what was your lower and upper for A?
I put in lower. Well, I put upper, which is 50.
Yeah.
And then for lower, I guessed, and I put 27, and I got 27.
So it should be the other way around. You want X is less than some value. So some value or less. So what would be your...
So would the lower be 50?
Lower would be 0.
Okay.
Yeah.
And the upper, you guess the number in.
Yeah.
It's 13.
So that one is 13. So K is 13. And so how do you go about B?
So for B, did we do what we just did, but with them flipped around, like what I did before?
Yeah. So go on.
So the lower would be 50.
No. If the lower was 50, then the upper would have to be 50. So this is like something or more.
Oh, so it's upper 50 and the lower we guess from.
Yeah. And they want less than 0.01 for this.
Okay. I got 29.
29. So lower is 29. And so R is 29. Let me just see. 13. 13. 28, they are saying. Did you try 28?
Do I try what?
Did you try 28?
Yeah, I got 0.016.
Let me see this one. So this is probability of 0.4. See there? Yeah, I'm getting the same. And 0.016, 28 or more. That's why. This one isn't or equal to.
Oh.
And so it wouldn't include 28. Oh, that's sneaky. Okay, let's try 8A.
Okay. So the lower 0, the upper is 40, the numerator is 40, and the probability is 0.1.
Right. Well, you get.
And then we guess.
So what is it that you guess for this one?
You guess the lower.
You want x is less than k. So you'd be guessing the upper.
Okay.
Yeah. I'll leave it. Or, well, okay, go on. Try A.
Okay.
So the largest value. Yeah.
Would it be 0?
Oh, really? Is it 0? Might be. Hang on. Let's see. So number of trials is 40. Probability 0.1. The lower is 0. Let me put in 1. So that's too big. Yeah, I think there might be a trick to this one though. Any idea what it might be?
No.
Yeah, so I notice it's not less than or equal to.
Yeah.
So is it just, it seems like even 0 wouldn't be included. Is it like a null set? So they're saying it's 1. Yes, because 1 wouldn't be included. And so k would be 1 because 1 isn't included.
Okay.
Alright, so that's tricky. Equals 1. Alright, that's enough of that. Let's see this thing. Statistical distribution. Let's try part C.
Okay. So this time we will be guessing the lower.
Yep.
Okay. So the upper is 0.09. Oh no, it isn't. Wait, is it?
Definitely not. They have to be discrete. They have to be whole numbers. It's like this is, number times.
Oh, it's 40.
Yeah.
Okay.
So I'll say lower is m or whatever.
I think it's 12.
And so is there any trick with this one? Because it's not or equal to.
Would it go down by 1, so it'd become 11?
Yes, because 11 isn't included. And so m equals 11 for question C. They're saying 12. Why are you doing this to me? Let's see, 0.05. Let's see. So 12 was the one that worked, was it?
Yeah.
And so it shouldn't include 11. So that's 40. And probability is 0.2.
Yeah.
So that's that. So that's too much. It had to be. Oh, were you looking at the first one, 0.09?
Oh, yeah, I was.
Okay, so 0.05. And so it's 11 did not work. Wait, we needed 13, was it?
I think so, yeah.
So 13, and so we put it back to 12. Yeah, okay, great. So you're just looking at the other one.
Yeah.
That's fine. That's fine. Cooking with gas. Find the probability that at least 10 of these listen to the thing. That's fine. Fewer than 2 defective. More than 5. 5%. So it's just that stuff. Okay, more than 12 plants have fruit. I think it's almost okay. So this is what we need to do. Yeah, let's do this.
Okay. So for this, I'll be guessing the upper.
I don't think you have to guess with this one. So she grows orchids. Probability 0.46. 25 plants.
Oh, so the upper would be 12, the lower would... No, the lower would be 12, the upper would be for 24. 25, sorry.
Very close. More than 12.
So it'd be 13, the lower.
Yeah.
I got 0.343.
So that is 0.343.
Yeah.
Let's say 5 sig fig.
0.3286.
That has 4 sig fig.
Oh. Wait, does 0 count as significant?
No, not at the beginning.
So it's 0.34286.
4, 2, 8.
86.
And that's better. You said 3286.
All right.
Okay, question C.
Okay. So now would the lower be 4?
Yeah.
And the upper, do you... Wait, but it says she takes a sample of 6, so would the numeric trial be 6?
Well done.
And then do you guess the upper?
Oh, upper is 6. And so basically, for the previous one, I just wrote like X is binomially distributed, 25 trials, probability 0.46.
Yeah.
This one, Y is binomially distributed, number of trials is 6. What's the probability?
Okay.
We want the probability that they contain more than 12 plants. 4 out of 6 contain more than 12 plants.
4 over 6?
It is 0.34286.
Oh.
Because that is the probability that they have more than 12 plants. And so to get the probability that 4 or more have 12 or more plants on them, then you have to sub it into that one.
Okay.
So try that. What do you get?
So for the probability, I sub in not the 5 significant figure number.
Yeah. And that's
Okay.
why I got it to 5 sig fig.
Yeah. And it gives us 0.10 or 0.10 0.11.
What is it? 110?
Yeah, 110.
Yeah, okay. 3 sig figs fine. They did that, that's fine. 3, 4, 2, yeah, great. Grand. Okay, so that, watch out for that one. Right, let's try this one.
Okay. So I got the lower would be 4, the upper would be 20, the numeric trial would be 20, and the probability is 0.3.
Yep.
That gives us 0.89291 to the 5 significant figures.
0.8929?
Yeah, and then 1.
291. Okay.
Okay. So now does the numeric trial become 200?
Mm-hmm.
Okay. And does the upper and the lower become 6?
Yep.
And the probability would be the 5 significant figure number, which is 0.89291.
I sure hope so.
I got 0.
Hmm. 0, eh?
Yeah.
Now that don't make a lick of sense.
I put lower and upper as 6.
So I can't get 6. Let's see this one. You sure your probability is good?
I think so.
Let's see. Lower is 6. Upper is 6. Trial of 2. How can it not land on 6? 0.89291. Is it just very small? Let's see. More than 3. these both sold in bags of 20. John buys 10 bags. Ah. Wait, how did you get 200? Buys 10 bags.
Because in each bag there's 20 bolts, right?
Yeah. I think 6 of these bags. I think 20 is a red herring. I think number of trials is 10.
Okay. I got 0.014.
So 0.0140.
4. Yeah.
There we go. 0.0140. And then the other one. Great. So let's see. 20 was a red herring. Well, they're sold in bags of 20, but this one up here was 20. You know what I mean?
Yeah.
And so they can match up. Okay, let's see this one. Alright, let's give it a go.
Okay. So would the probability be 0.5 for this?
For part A or C?
A.
I believe probability is 0.6.
Okay.
So they're kind of phrased it in a way to throw you off with
Yeah.
that 50%.
So would the lower be 12?
What is 50% of her arrows?
10.
Yep.
So is the lower 10 then?
Yep. Lower is 10. They just phrased it that way to throw you off a bit.
And the upper is 20?
Yep.
I got 0.87248.
8. Okay.
And then for this next part, you do 0.5 as the probability.
No, you fell for it again.
0.6.
Still no. What is the probability that she hits the bullseye with at least 50% of her arrows?
It's the probability we have now. 0.87248.
Yeah. And it says here she shoots 12 sets of 20 arrows.
So would the new trial be 12?
So number of trials would be 12, yeah.
And the upper would be 5.
Very good.
And the lower would be 0.
Mm-hmm.
And you get 2.4098 times 10 to the 4. Minus 4, sorry.
So 1, 2, 3, 4. And what was it? 3 sig fig?
241.
241. 2407. Great. 4 zeros. That's it. So the 20 arrows at a time, 20 arrows, and so those two, like it's the same probability, at least 50%, at least 50%.
Yeah.
So it's the same probability as the previous one. Let's see. Yeah, they threw you off with that 50%. It's just half of our arrows, 10 arrows. So this one is for cumulative. That's the archer one. Yeah. Okay. Hang on, will I just delete it? Yeah, I'll just delete it. I was duplicated in the wrong place. So this one's not easy. So this is, right, we're going to try this one.
Okay.
Let's give this a go.
So would it be X binomial distribution?
Yeah, X is binomially distributed.
And then is it 10?
Yeah.
And then X?
Well,
Would it be prime numbers then?
so what are the prime numbers on a dice?
Between 0 and 10?
No.
On a dice?
Yeah.
2, 3, and 5.
Yeah, so what's the probability you roll a dice that lands on a prime number?
A half. So 0.5.
Yeah, let's go with 0.5. Okay. B. Oh yeah, 2 assumptions. We did that last time.
Yeah.
Alright, B. Find the probability that David rolls 4 prime numbers.
Okay. What is that 0.125?
0.125. How'd you get that? What was lower, upper?
He did it 4 times. I just did 0.5 divided by 4.
So we haven't done any. We haven't learned anything, I see. Well, it's what you could do. See, this is, he rolls 4 prime numbers. He rolls the thing 10 times.
Yep.
So 10 times.
So the number trial is 10.
Number trials is 10, yeah.
Probability is 0.5.
Yep.
The upper is 6.
No. He rolls 4 prime numbers in 10 rolls.
So the upper is 10.
No. Not 4 or more. So probability it lands on a prime number is a half. We want it. He rolls it 10 times and it lands on a prime number 4 out of those 10.
So it'd be 6. No, it wouldn't be. It'd be 4.
It's 4. Lower is upper is 4. Exactly 4.
So the lower would be 0.
No, not 4 or
It'd be
less. No, not 4 or less. Not 4 or more. 4.
It says 4.
Yeah.
I got 0.20508.
8. Okay, so the probability that X is 4 is that. Part C.
So would the number trial be 7?
Yeah.
Probability would be 0.20508.
Mm-hmm.
So when it says exactly twice, does that mean the 4 has to be halved.
Is probability wise 2, basically. Exactly 2.
So it'd be 2 for lower and upper.
Yes.
And you get 0.280.
0. 0.280, great. Yes, and so this one, this is binomial probability distribution.
Yep.
So not cumulative, but it uses that same subbing it in from the previous one.
Yeah.
Great. And so probability distribution, lots of stuff. That's that chapter though. We should do our test. Let's see this thing. Construct a table for this. All right. How do we do this?
Okay, so you'd have x in the top,
Mm-hmm.
and it'd go from 1 to 6. And then, yeah, you'd have that, and then you put 1 for, you sub in every number, and then put the answer in the below the number that you subbed in.
Yeah. That's good. And then, so what's the first one?
The first one is 1 over 21, or, yeah, just 1 over 21.
Yeah. And how about part B?
Okay. So for this, would you put in the probability? What would you put in as the probability?
Probability x is between 2 and 5. What's the probability of that x is between 2 and 5? So what values can x take?
3 and 4. Or 3 over 21 and 4 over 21.
What's it about these two are different?
Wait, well, those are different, so what about them?
So this is, they don't look the same to me. What's that
Oh,
about?
yeah, so it has to be above 2. It can't be 2, but it can be 5 or below 5.
Yes. And so 3, 4, or 5?
Yeah.
And so, what's that?
You just add them together, which gives you 12 over 21.
Great. That's good. Let's see this one. How would we find R?
Okay. Would you just add all of them, then take away from 1?
Yeah. And let's say it's 0.2. Part B.
So it's the numbers between equally 1 and below 2. So it'd be the 0.2 and 0.3 add 0.2, which gives you 0.7.
So it's 0.7. Great. Let's see. I think you might be. So how would you start this one?
Okay. You'd you'd draw the table out as p brackets x equals x in the bottom left, and then you'd have x above it, and then along that line you'd have 1, 2, 3, and 4. And then to work out the numbers, you just sub in each number into the equation, and then put the answer under.
Good enough for me. Sounds like you know what you're doing. Let's see this one. Alright. Why are they always weird? Why can't they just be straightforward? Alright, how do we find the value of k?
Okay. I don't know how you'd find k.
Make a table.
Okay, so you have y equals y on the bottom left. And then y in the top, you'd have 1, 2, 3, 4, and 5. And the answer for the first one is 1 over k.
Uh-huh.
And then it just goes up. So 2 over k, 3 over k, 4 over k, 5 over k.
Yeah.
And then you add them together.
Yep.
Which gives you 15 over 5k.
Doesn't work that way. You failed primary school. 15 over k. Add the numerators, copy the denominator.
And then what would you make it equal? Would you make it equal to
You tell me. What do probabilities add up to?
1? So you times by 15 on both sides,
Times by k on both sides.
which gives you 15 equals k.
Mm-hmm. How could you check your answer?
Could you sub in 15 for k and then add them together?
Yeah. So we have 1 over 15 plus 2 over 15. Yeah, what will they add up to?
15 over 15, which equals 1.
Yeah. Great. Let's see this one. He rolls a dice again. Yeah. Yeah, construct a table. Make me work hard with this stuff. Don't make me work hard. This looks alright. How about this one?
Okay. So for this, the lower and the upper will be 20.
Mm-hmm.
The neutral will be 30, and the probability will be 0.73,
Yeah.
which gives you 0.114.
0.114. How about C?
Okay. So C would be same probability, same neutral. The lower will be 12. Upper will be 25.
Sounds good.
Which gives you 0.937.
0.937. Great. Let me see. 2, 6, 7. Right. Okay. Let's see this one. Do you remember A?
So for this, would you do numeral will be 10. Numeral.
What part are you looking at?
Oh, we're doing A. Oh, we're doing A. I was looking at B.
Yeah. Do you remember A?
Doesn't it have to do with the frequency?
No. Binomial?
They have to be a fixed.
Yep.
A fixed probability.
Yep. What
And
else?
a fixed variable.
A fixed number of trials?
Yeah, fixed number of trials.
Mm-hmm. Another way of saying fixed probability is trials are independent, but
Okay.
they appear to want us to say that.
Okay.
So maybe they know something I don't. There's one more thing though. Easiest thing. How many wheels on a bicycle?
2.
And so this one, 2 possible outcomes.
Okay.
In this case, success or failure. Let's say the rest of that isn't bad. It's not all normal stuff. Maybe what would be part C?
So for this, would the probability be 0.99?
No. We want the outcome to be like 0.99.
Okay.
You know what? That's a weird one. That's a weird one. Find a suitable distribution. At least. Yeah. Fewer than yellow. Exactly that. And then we have D. They're the same. Oh, I can't take any more of these. That's it. Yeah. Okay, so that's stuff. What do you give yourself?
Tick. Found it pretty easy.
Yeah. Well, I'm glad one of us did. I have to wrap my head around that stuff. Yeah, and so next time you're on chapter 7, which is hypothesis testing.
Okay.
Yeah. Any questions for me in general?
No.
Alright, well done, Adam. You did great. I look forward to talking to you again next time.
You too. Bye.
Cheers. Take care. Goodbye.